Jai Hind everyone. I am Shruti Jain, Assistant Professor, MCA Department, Ajay Kumar Garg Engineering College, Ghaziabad. The topic that I am going to discuss today is Propositional and Predicate Logic, that is covered under the subject Discrete Math, and the subject code is BMC 104. This is meant for the first year MCA students, the first semester. So let's understand what logic is. So if we talk about the general meaning of a logic, it is the systematic use of the symbolic techniques and the mathematical techniques which determine the forms of the valid deductive argument. Argument is basically anything that we talk about and we derive some conclusion out of it. So it is, and we can check whether it is valid or invalid. So here it demonstrates the validity of our reasoning. For example, if we say that Lucknow is the capital of Uttar Pradesh, that means we can validate whether Lucknow is a capital of Uttar Pradesh or not, and in validation we will get the result either in yes or no. So a proposition is basically a declarative sentence which can be either true or false, but not the both. Like we are not in the dilemma whether it is that it can or it cannot be. The second example that we have is 9 less than 4. So this again would be either true or false, but not both. Like in this case, it is false. Next, 1 plus 1 is equal to 2. This is again true. That means if it is true, it cannot be false. So these kind of examples talk about the proposition. Now let's see what are some of the examples which are not a proposition. What time is it? Now here you cannot give the answer in yes or no. It would be the time that the other person would be giving. So it could be either true or false. Read this carefully. So again, this is a kind of a sentence which does not give us a result in yes or no. So these are some of the sentences which are not a proposition, where we are not getting the answer in yes or no. But these are some of the sentences where we get the answer in yes or no. So propositional logic, if we talk about, the propositional logic is a branch of logic which deals with the reasoning about the propositions. So when we are writing the propositional propositions, we normally use the variables in letters as the propositional variables. Like the P says all math students wear glasses, so that would be a proposition P. For Q, we have all electronic engineering students know how to wire a plug. So this is how we create the propositions in the predicate or the proposition logic. Negation. Negation is just the negative of the proposition. So if we say that there is a proposition P, then the negation of proposition P is denoted by the symbol negate of P. For example, if we say that Delhi is the capital of India, the negation of P would be Delhi is not the capital of India. If we say that 2 plus 5 is 7 is equal to 7, so the negation of it would be 2 plus 5 is not equal to 7. So this is how we do the negation of any of the proposition. The next example is find the negation of Michael's PC runs on Linux, and this we need to express in the simple English. So this is the P. So Michael's PC runs Linux. The negation of it would be the introduction of the not. So that would be Michael's PC does not run Linux. Or it is not the case that Michael's PC runs Linux. So we need to introduce this not over here. This not, as soon as this not is introduced, we get the negation of the proposition. Now we have the bit operations. So what is a bit? It is basically a binary digit which has a value either 0 or 1. So 0 is represented as false in general and 1 is represented as true. So the binary operations, they correspond to the logical operators where the false is replaced by 0 and true is replaced by 1. We have some of the truth values. The first one is P and Q. The symbol talks about the and. When we talk about the P and Q, this P and Q says when both the values would be true, only then the result would be true, else the result would be false. So P and Q give 0 and 0 gives 0, 0 and 1 gives 0, 1 and 0 gives 0, 1 and 1 gives 1. So when both the values would be true, only then the result would be true, otherwise the result would be false. The next one that we have is P or Q, which says if both the values are false, only then the result would be false, rest it would be true. So when both the values are false, the result would be false, rest all the values would be true. Exclusive OR says when we have the different values of P and Q, we'll get the result as 1. For the same values of P and Q, we'll get the result as 0. So this is exclusive OR. Exclusive OR says when the values are same, we get the result as 0. When the values are different, we get the result as 1. That is, if P is 0, Q is 1, or if Q is 0, P is 1, in that case, the XOR would be 1, would be true, otherwise it would be false. The NAND, that is the, let's look at the conditional, P implies Q. P implies Q says that if the P is true, if the condition is true, the result needs to be true always. Let's take an example. We have an example saying that if it is raining, carry an umbrella. So, P implies Q. If it is raining, carry an umbrella. It will always give you the true result. Next, if it is not raining, do not carry an umbrella. If the condition is false, the result could be anything. So, if it is not raining, it is not necessary that you have to carry an umbrella. So, P implies Q would be true. The next, if it is not raining, I can carry an umbrella because it might be very hot or sunny and I need to carry an umbrella. So, if it is not raining, then also I can carry an umbrella. That is again true. But if it is raining and I am not carrying an umbrella is a false condition or is false. Because if the condition is true, the result of it has to be true always. So, if it is raining and I am not carrying an umbrella, it would result a false. That is P implies Q. Biconditional is basically P implies Q and Q implies P. So, when we have P and Q and P implies Q and Q implies P, we get the biconditional P if and only if Q. That means if we talk about Q implies P would be 0 over here because the condition is true but the result is false. Hence, P and of both of them would be 1 and 1 over here and this would be 0. So, this is P if and only if Q. Then we have NAND, that is not of AND. Not of AND is just the negation of this. So, here P and Q is 0, 0, 0, 1. NAND would be 1, 1, 1, 0. So, that is 1, 1, 1, 0. Similarly, for NOR, we have the negation of OR. So, here we have 0, 1, 1. Here would be 1, 0, 0. So, this is how we calculate or we find out the truth values of any of the compound statement that is given. Propositional equivalence, if we talk about, so when we talk about the propositional equivalence, we talk about three things. That is a tautology, contradiction and contingency. Tautology is when we have the result to be true, that is a tautology, that is P or the negation of P. Whenever I have the P and the negation of P and I do the OR of it, in that case I will get the result as true, that is a tautology. Contradiction is when I get fallacy, false in the result. All the values in the result are false, then it becomes a contradiction, like we have P and negation P. Contingency is which is neither a tautology nor a contradiction. So, we get any value that could be false or true in the result. That means it is not the whole of the true or it is not the whole of the false. So, that is P implies the negation P. Argument. By argument we mean that it is a sequence of statements which ends with a conclusion. So we have some of the propositions P1, P2, Pn which are called the premises, and the result of it is Q, that is known as the conclusion. The arguments are written as P1, P2 till Pn, which implies the Q. Any argument is a valid argument if Q is true whenever all these premises are true. Otherwise, we get a fallacy where P1, P2, Pn are true, but the result of it is not true, or the result is true but one of the propositions are not true. Hence, we get a theorem that P1, P2 to Pn, they are logically connected to Q. This is valid if and only if Q is true whenever the AND operation of all the propositions are true. That is, P1 and P2 till Pn implies Q is a tautology. So, whenever we need to check whether an argument is valid or invalid, we just need to AND all the propositions with the implies factor, and we need to find out whether it is a tautology or not. So, procedure as we have just discussed will normally work upon this, where we have all the propositions, we do the AND operation, use the implies, and then we check whether it is a tautology or not. So, here we have one of the question where we say that P implies P or Q. So, we have P, we have Q, we already calculated P or Q over here. Now, we will check for P implies P or Q. So, when we do this implication, we say that when the condition is true, the result is false, only then we will get the result as false. So, we will be using this P, we will be using this P or Q. So, the condition is false, the result is false, the result is false, we get the result as 1. The condition is false, the result is true, we will get the result as 1. The condition is true, the result is true, we get the result as 1. The condition is true, the result is true, we get the result as 1. Now, this 1 represents the true, that is when the result here is a tautology, we call this as a valid argument. Hence, this is a valid argument. We have one more example where we say that P if and only if negation of Q does not logically implies P and Q. So, P implies Q. So, P if and only if this will be using. Here we say that if both the values are different, we get the result as 0. If both the values are same, we get the result as 1. So, these two are different, we get the result as 0. These two are same, we get the result as 1. These two are same, we get the result as 1. These two are different, we get the result as 0. P implies Q. When the condition is true, the result is false, we get the result as false. So, P implies Q, this is true, this is true, this is false, and this is true. So, we have 1, 1, 0, 1. Now, it says that we need to check whether this is it logically implication or it does not logically imply. Let's consider it as A, this as B. So, we need to basically find out A implies B. Let's calculate A implies B. A implies B, 0 and 1 gives 1, 1 and 1 gives 1, 1, 0 gives 0, 0, 1 gives 1. So, this is a contradiction. It is not a tautology at all, because here we get a false condition. Hence, this is not a valid argument. So, this is how we calculate the validity of an argument using the truth table. So, if we look over here in the validity of an argument, the validity of the argument is done when we have the set of propositions given to us. We do the AND operation of them, like here in this case, we had only one proposition P or we had only one proposition where we have P or Q, and then with this P or Q we calculated this P implies P or Q. This whole, if it was a tautology, we called it as a valid argument. If it is not a tautology will, or here if any one of the situation, like here in this case we had one value as 0, in that case this is not a tautology and hence it does not imply logically that the proposition and the result are valid. Like in this example, we have P if and only if not Q. This is one proposition and this is the conclusion. So what we did, we calculated this value separately. Then because this is the proposition, this is the conclusion, the proposition always imply the conclusion, we calculated A implies B. We could have directly written it as P if and only if negation Q implies P implies Q, but that sometimes become a lot of confusing. That is why what we do, we name this as A, we name this as B, and then we try to calculate A implies B. So once we do this in this manner, A implies B, it is easy for us to identify the implication. Coming back to this truth table that we just discussed. So here we already saw that P if and only if Q is a biconditional, which says that it is P implies Q and Q implies P. P implies Q and Q implies P here means that when in the P implies Q, if we look over here where we have 1 and 0, we get the result as 0. So when we talk about P if and only if Q, here again in P if and only if Q, where we have 1 and 0 and 1 and 0 in both the cases, in the opposite way, we get the result as 0. Whenever both the values are same, we get the result as 1. So whenever you are calculating any of the argument, you just need to identify what all are the propositions and what is the conclusion. In the propositions, that is the premises, do the AND operation, perform the AND operation if you have multiple premises, and then apply the implies to the conclusion and you will get the result. That is all for today. Thank you.